Hey everyone, and welcome to The Explainer. I am absolutely thrilled to guide you through today's topic. We're looking at the story of an incredible technological comeback for an entire nation. It's a story of science, of overcoming just immense doubt, and of a brilliant team of engineers who basically had to relearn how to reach the stars. We're talking about FedSat and exactly how it reignited Australia's ambition in orbit. Okay, let's dive into this with a number: 35. Just let that sink in for a second. Imagine waiting 35 entire years, because that was exactly how long Australia went without launching another Australian-built satellite. Now sure, their scientists were still contributing to various international space missions during that time, but the country itself hadn't actually built and operated its own satellite since WRISAT was launched way back in 1967. We're talking about 3.5 decades of total silence on the manufacturing front. So that brings us to Section 1, a 35-year drought, Australia's lost generation in space. Looking at how this played out chronologically, the story starts on a really high note in 1967 without successful WRISAT launch. But as the decades dragged on without any sort of follow-up, we move into the late 1990s. And this was a critical period because growing doubts really started to cast a shadow over the scientific community. The long pause made people seriously question the nation's capabilities, leading right up to the incredible milestone we see in 2002 with the FedSat launch. As this quote captures perfectly, by the late 1990s, the stakes were incredibly high. Many wondered whether the nation could once again develop advanced spacecraft. It wasn't just a matter of, finding the funding. It was a full-blown crisis of confidence. Could a country that had been out of the satellite building game for over a generation just jump back in and create something capable of surviving the harshest environment known to humanity? Let's look at how they answered that in Section 2, the Centenary Space Mission, reigniting the spark. The solution came in the form of FedSat, which is short for Federation Satellite. Now, this project was conceived as part of a major national celebration, the centennial of Australia's Federation. But I want to make something very, very clear here. This was much more than just some symbolic anniversary project. It was recognized as a golden opportunity to deliberately rebuild Australia's space capability from the ground up, and, crucially, to train an entirely new generation of engineers and scientists. To achieve this monumental task, they needed an unprecedented team. The project was spearheaded by the Cooperative Research Center for Satellite Systems. This organization brilliantly brought together universities, specialized research groups, and industry partners from all over the country. Think about it. Students and researchers who had never built a satellite, mostly because no one in their country had done it for decades, suddenly found themselves united with this singular, massive goal. They basically had to reverse engineer decades of lost institutional knowledge. All right, Section 3, inside the FedSat satellite. Big science, small package. Now, what's really interesting about this slide is that number right there, 58. 58 kilograms, that is incredibly light. After decades away from spacecraft construction, the team managed to design and build a satellite that weighed roughly the same as an average teenager. But hey, don't let that small footprint fool you. They crammed an entire, highly advanced scientific mission into those 58 kilograms. Despite its size, FedSat carried a remarkably sophisticated payload. It was tasked with studying the Earth's atmosphere using signals from GPS satellites, demonstrating an emerging and highly technical method known as GPS radio occultation. To put that simply, it means measuring how GPS signals bend as they travel through our atmosphere to accurately figure out temperature and humidity. On top of that, it carried experiments to actively investigate space weather, tracking things like solar winds and magnetic field disruptions, while also testing out new communication tech and a bunch of other scientific instruments. It was just an absolute multifaceted scientific workhorse. But you really have to remember the intense pressure this team was under. Years of painstaking work went into the design, construction, and testing phases. Every single subsystem had to function flawlessly. Every tiny component had to survive the brutal, unforgiving vacuum of space. And for many members of this team, this was their very first time building real operational space hardware. The margin for error was literally zero. Let's move to Section 4 and see how this builds. Liftoff and legacy, the return to orbit. The moment of truth finally arrived on December 14, 2002. A Delta II rocket roared to life and lifted off from Vandenberg Air Force Base over in California, carrying the 58-kilogram FedSat into orbit. Minutes later, the critical moment of spacecraft separation occurred. And then, the engineers back in Australia entered the absolute most nerve-wracking phase of the entire decades-long journey, the anxious wait for a signal. I mean, just imagine being in that control room. You've poured years of your life into this. You've literally carried the weight of a 35-year national drought on your shoulders. And now, you're just left staring at the screens, asking these agonizing questions. Would this satellite wake up? Would it communicate? Because all the testing in the world couldn't guarantee what would happen in those silent, tension-filled minutes after launch. And then, the ultimate relief. The signal arrived. FedSat was alive. For the first time in 35 years, Australia once again had its very own satellite operating in the vacuum of space. The decades of doubt were instantly washed away by the data streaming back from orbit. And over the following years, FedSat would go on to successfully carry out its scientific missions and validate all those new technologies. And this brilliantly illustrates the overall journey. If RESAT back in 1967 represented Australia's very first step into orbit, then FedSat in 2002 unequivocally represented the nation's renewed ambition. It proved once and for all that the long gap wasn't the end of the story, but rather a dormant period before a major technological resurgence. But here is the crucial point to take away regarding FedSat's true legacy. Yes, it successfully conducted vital GPS radio occultation and space weather science, which is amazing. But perhaps its greatest, most lasting achievement was far less visible than the hardware itself. It trained an entire generation of modern Australian space engineers, researchers, and industry leaders. It laid the foundation for the country's growing space sector, proving beyond a doubt that they could once again design, build, and operate advanced satellites. Which leaves us with this final, thrilling thought. FedSat proved that the journey back to space had truly begun. So, if one 58-kilogram satellite, built by a team who hadn't done this in 35 years, could reignite an entire nation's space industry, what in the world will the generation of engineers it trained launch next? Thank you so much for joining me on this explainer. Keep wondering, keep learning, and I'll catch you on the next one.